This question, based upon deadlock, we need to identify which of the given statements are correct. First one says that circular weight is a necessary condition for the formation of deadlock. There are four necessary conditions for deadlock. First one is mutual exclusion. Then we have hold and weight. Third one is circular weight, which is given in the option. And the last one is no preemption. All of these conditions are necessary for a deadlock to occur. Circular weight is one of them, hence the statement is correct. In a system where each resource has more than one instance, means they are talking about a multi-instance case. A cycle in its wait for graph indicates the presence of a deadlock. This wait for graph is a subset of a resource allocation graph RAG, in which there are the processes and the edges show which of the resources they are occupying. If there is a cycle in this particular graph, then it may or may not indicate a deadlock, because if it is a multi-instance graph, then a cycle is just a necessary but not a sufficient condition in order for the deadlock to occur. But if it was a single instance graph, then a cycle would definitely indicate a deadlock. Hence, this statement is incorrect, because in this case, cycle does not indicate the presence of a deadlock. In the current allocation of resources to processes leads the system to unsafe state, then deadlock will necessarily occur. If currently the system is in the safe state, but in future it might go into unsafe state, then we cannot say for sure that deadlock will necessarily occur or not. It may or may not take place, because deadlock is simply the subset of unsafe state. Unsafe state does not always guarantee the presence of a deadlock. So the statement is incorrect. Lastly, we have in the resource allocation graph of a system, if every edge is an assignment edge, which means if we have a process P and this is the resource R having a single instance, or we can also have multi-instance. Let us say there are two processes. Each of them are holding one resource each from this. If every edge is an assignment edge, this is what we mean by an assignment edge, means a resource instance has been assigned to some process. If all the instances are like this in that particular graph, then it will indicate that there is no process waiting for occupation of any resource. All the resource requirements of all the processes are already satisfied. There is no hold and wait in that particular case. This was a necessary condition for deadlock. It is not holding true. Hence, deadlock will not take place in this particular case. So the system is not in the deadlock state is correct. So the correct options for this question are A and D.